All right, welcome back. Now we're on number 5, okay? So it says find the mass and the center of mass of the lamina. I know you don't know how to find the center of mass. We're going to make that a little mini lecture as part of this problem, okay? So we've got a rectangle, and this is x. X goes to A, is that correct? Yeah. And then y goes to B. Okay? And let's, for part A, it says rho equals K. Who can explain what that means? It's a constant what? It's a constant density. So we should already know the mass of this thing. What is the mass? Yes, good. It's ABK. Does that make sense? Hey, I'm going to show you that the calculus supports that, okay? KY, so KB dx. I have no idea because I need your help not doing those kind of things. Thank you. Okay. And then that's going to be x KB from 0 to A, right? So that is A, B, K. Does everybody follow all that? All right, now we should also know what the center of mass will be then. What will the center of mass be, Ratchet? Uh-huh. A over 2, comma, B over 2. Eventually, you won't, I don't need you to show me any work on these. If you know that's the answer because of symmetry, then write it down. Okay, but I'm going to show you how we're going to find that with calculus now. Got it? You remember my Mr. G, Mr. Ullin teeter-totter comparison? All right, so hopefully, here's how we're going to, hopefully you'll understand this then. Center of mass, just COM. We're going to call it X bar, comma, Y bar. You find this in 2 different pieces. So first you find X bar. X bar is the double integral over the what do we call these things? Lamina region. Remember that we took my distance from the center and multiplied it by my mass? So x is the distance, so we multiply it by a factor of x. And then we just do the same thing. Rho of x comma y dA. Rho is the density function. So basically, oh, we're not done yet. We're not done yet. The density in this one is constant. I am giving you the general equation on how to find x bar. Then I take that and I divide it by the mass, just like in my example over here on the board. My example from the Blackboard site. Well, what's my mass? It's almost the exact same looking thing. So that is how I find my x bar. Do you understand that? So what will my y bar be then? The only difference is on top, I will now have an extra factor of y in it. Times the density, times the area. And you can think about area as volume here. Okay? So, we already know that our mass is ABK. We're going to have to remember that. So for our x bar, it's the double integral from 0 to A 0 to B of x times k dy dx all over m. You follow? I'm going to forget about the m for a little bit. So it's the integral from 0 to a of xky as y goes from 0 to b. So xkb dx. And that is x squared over 2, right? X squared over 2 as x goes from 0 to a. So it's going to be a squared bk over 2. Did everybody follow that? I skipped a couple integration steps because we won't have time if I don't. So now how do I find my center of mass, or my x portion of my center of mass? I got to take that thing and divide it by ABK. B's are gone, K's are gone. My A squared becomes an A, and my x bar is equal to what? A over 2. Perfect. That's what we wanted, right? And what's our y bar going to be? So our center of mass is A over 2, comma B over 2. So far, so good? Now, hopefully, we trust these calculus equations for center of mass. And now we're going to go on to part B of the problem. What's different in part B of the problem? What is my density function? Ky. So what isn't going to change in this? My bounds won't change. Excellent. My x bar should stay the same. Is there any variable density over x? Okay. So where is our change in the problem? It's in our density over y, right? Where is this function, or where is this lamina most dense? At the top. So what would you expect to happen to our center of mass? It should be somewhere up here, right? Centered from x to y, but north of center. Sorry, centered over x, but north of center over y. All right, so let's see what we get. Now we got to recalculate the mass. X goes from 0 to A. Y goes from 0 to B. Ky dy dx. Solve this integral and we find mass. That's ky squared over 2 as y goes from 0 to b. So from 0 to a, that's kb squared over 2 dx. Sorry. All right, so that's going to be x kb squared over 2 as x goes from 0 to a, and we're going to have a b squared k over 2, and I'm sorry that I keep changing the order. What did I just find again? Our mass. What has happened to our mass compared to part A? It's gone up by a factor of b over 2, right? We've multiplied it. It's gotten bigger. Our mass has gotten bigger. That makes sense because our density has gotten bigger. Got it? Okay. So now, X bar. This is how I would expect you to do your homework or your test. X bar equals what? Oh no, don't do it. X bar equals A over 2. We no longer need to prove to ourselves that the calculus works. So you've got to use common sense. Maybe not common sense, but you got to use double accelerated common sense. Okay? Y bar, it is not intuitive, so we have to use calculus. So somebody help me set this up.
I think if you go dx dy, I think it's easier.
Ooh, I'm not going to do that, but I appreciate that.
No, it's just, well, I mean, yeah, you have to do
0 to A. I think your integration probably makes more sense because you get rid of the y's right away. I like it, Lexi, but I'm not going to do that. 0 to B. Y, ky. So eventually we're going to make that ky squared. dy, dx. Okay. All over m, which will come back to the m. So the top is equal to the integral from 0 to a, y squared, so that's y cubed over 3k as y goes from 0 to b dx. The top is equal to, b cubed integral from 0 to a of b cubed k over 3 dx. So that's basically a b cubed k over 3. Well, I shouldn't circle that at all, because what have I not done yet? Haven't divided by my mass. So divided by a b squared k over 2. So, I don't know, sorry. I just don't want to screw this up at this point. So ab cubed k over 3 times 2 over a b squared k. K's are gone, a's are gone, b squared's gone from the bottom. 2/3 b is our y bar. So this point right here is a over 2, comma 2/3 b. And I would not have guessed that. I think I would have guessed 3/4. Okay, does that make sense? Now, part C, I think now that we trust the calculus, we should be able to just write the answer down. Okay, so part C says, now my rho, or my density function, is kx. So what do you think that will be? Excellent. No, you don't. Does it say to find the mass? Okay, so we should be able to just, again, use symmetry to find the mass. What will the mass be, do you think? A squared bk over 2. And the center of mass should be 2/3 a, comma b over 2. And if you could follow all of that, you're in good shape for right now. You really are. Okay? Hey, AJ, can I get a boom? Thank you, AJ.